Hi, my name is Elvia Renova. I'm a research assistant of mechanical engineering at the University of Texas at El Paso. Today, I'm going to talk about how to create a Voronoi tessellation diagram for niobium silicide in order to find the modulus of elasticity using ANSYS as the finite element software. I'm going to talk about my motivation for this project, background of the project, objectives, geometry, mesh optimization, discussion, and at the end, I'm gonna state my conclusion. Niobium silicide composites are being studied to prevent oxidation of power plant components subjected to temperatures above 1,300 degrees C. In this study, we discretize the sample using tessellations and the finite element models in ANSYS to find the modulus of elasticity. As you may know, the turbine blades are subjected to high temperatures at the exhaust section of the turbine. So there is a need for a low weight but high performance turbine blades. To meet this need, niobium silicates composite materials are being investigated. According to some researchers, we can prevent oxidation of turbine blades due to high temperatures by applying coatings to the turbine blades. However, the coating material doesn't last the lifetime of the blade. Therefore, the blades need to be removed and coated again, and that's a time-consuming task. Therefore, the goal of the project is to investigate the niobium silicide polycrystalline material using ANSYS. In order to do this, first we need to create an hexahedral mesh using Dream 3D, then import the file into Abacus, then into ANSYS, and then create the properties, boundary conditions, tensile forces, and obtain the strain, and in that way the modulus of elasticity. Dream 3D controls the orientation and morphological aspect of the structure. There is a good tutorial in this picture that you can find in YouTube. After creating the geometry, the input file can be exported into Abacus or ANSYS, just directly into ANSYS. Here is a picture of the tessellation in Abacus. And here you can see 3 pictures of the hexahedral mesh in ANSYS and the number of nodes and elements that were generated the first time a sample was created. Since it was symmetric, a smaller sample was created later on. And you can see on this image that the mesh or the input file was submitted to ANSYS, and then ANSYS created grain sets. After creating the grain sets, we need to change the material properties and do the calculations and do the simulations and do the calculations for the modulus of elasticity. Unfortunately, I'm gonna